Hi, thank you. So my name is Jakub Pokrywka. Okay, so I'll talk about my work with my PhD advisor, Filip Graliński, temporal language modeling for short text document classification with transformers. I think everybody knows what is text classification. So given a text, we want to assign a label, for example, positive or negative sentiment, or one of a few classes. But we wanted to convert this task to temporal text classification, which is given a text and a date, for example, timestamp, to predict a label. So we used two data sets, which are originally for text classification, but because there were some timestamps, we are able to use it for our task. So first one is very popular data set, sentiment 140, which is a data set of tweets of 140 characters and label of positive or negative sentiment associated with it. And the next data set is not so popular, Ireland News, which is a set of news headlines and categories assigned to it. It's available in Kaggle. Okay, next slide, please. Yeah, so this is the sentiment 140 dataset. For example, you have a text at make news. I love Santa Barbara in the text, and it's a positive sentiment, so category is positive. And we have also timestamp 2009 May 31. So there's a timestamp, and we also converted it to fractional year format, which is integer of year followed by part of the year. So, for example, if it's May, it's 2009, 4110. So if it's close to January, it will be, for example, 1 or 08, something like that. Okay, next slide, please. And the second data set, which we focused on more, because the first data set was only of time span of 2 months, and this Ireland News data set has time span of over 20 years. It's articles from the Irish Times newspaper, which are available on their website. And there is an article, there is a headline, and we, in our data set, we only use headline. This, for example, Sudan claims it is disarming militias, that's all. We don't use the rest of the text. And we have also date and category. For example, in this case, it's news. Okay, next slide, please. So is the same. We have headline, Sudan claims it is disarming militias, and timestamp, fractional year, and category. We have several categories like news, sport, lifestyle, business, etc. Next slide, please. And here are some statistics. So we believe that there are some information in the text which are correlated with time, but there is also obvious correlation. For example, there are more business articles at the beginning, and it's the same for other date factors. Okay, next slide. For example, month. Next slide, and for example, day and the weekday. Next slide, please. And we see that there are a lot of sports news at Friday, and more business news on Monday or Tuesday. Next slide, please. So the first important task we have created is this temporal classification task. The metric is accuracy, and given an input, which is timestamp and text, we want to predict a category. In this example is news. So we have also two additional challenges, which is temporal word gap filling. It's the same as closed task or mask language modeling, which is a very popular pre-training objective for transformer language models. Metric is perplexity. For example, given a text, given a timestamp and text, we've masked out a word. For example, new home education guidelines, mask school teachers. We have to predict masked out word. In this example is favor, because in this original sentence, there should be new home education guidelines favor school teachers. And the third additional task is fractional year prediction, which is given a text, you have to predict a fractional year. Metric is root mean square error. Is a little bit unpopular to predict continuous variable in natural language processing. It's more popular to predict some class. Okay, so next slide, please. But why do we want to use this temporal metadata in language modeling? There are some research topics in temporal topics, but most of them focuses on semantic shift detection, which is detecting when a word changes its meaning. But we want to focus more on downstream tasks like classification, and why this is important for us. Because for example, when we search in some information retrieval system, for example, eBay or Amazon, for an umbrella in summer, probably we are looking for protection from sun. And if we are looking for an umbrella in winter or autumn, we are probably searching something which will protect us from the rain. And these two types of umbrellas are different. So we think that it's very useful to improve language model using this information, which is very easy to possess, because timestamps are available in most internet corpora, on which big transformer models are pre-trained on. For example, Wikipedia, Reddit, corpora, Common Crawl. Every corpus has items with, for example, timestamp. It's available in, for example, in Reddit dataset. So we can pre-train these huge models on text and also on dates. And we believe that incorporating this information will improve language models, not only because it's data set bias, but also because the language changes over time, linearly and cyclically. Because, for example, we have better. For example, we are more positive in Fridays than in Thursdays, so we can use this information. Next slide, please. But what are research questions we want to address? First question is, does temporal information can really improve language models on downstream tasks? In our case, it's mostly it's mostly temporal classification, so text classification. And what is the best way to incorporate data into a model? Okay, next slide. So we wanted to base on transformer model, which is state-of-the-art language model, which everybody now uses in NLP. So we choose English Roberta, which is transformer architecture. It is pre-trained on large corpora of English text. And usually it's pre-trained like other big language models on Corpora with some objective like mask language model objective, and later it's fine-tuned to a downstream task. In our case, text classification. And I think most of the audience knows what is transformer architecture, but it's big feed-forward neural network with attention mechanism added to every layer. And at the very beginning of this network, there is an embedding layer which embed every token, depending on this token. For example, the token can be word, and to every token there is added an position embeddings. Position embeddings because transformer architecture is feed-forward, and we want to add information about whether this word is first or second and third or the last, because without this we would lose the information about the sequence. Okay, next slide, please. So we use this base model, and we fine-tuned it just as is, which is node date model. We have a label for it in our tables, and this is our baseline models, and we developed 3 approaches. First, which incorporated date into our transformer model, which is first date as stacked embeddings. Second is date as embeddings added to every input token, and third is date as regular text. Okay, so the next slide, please. So the first approach is stacked embedding date. So we trained embeddings for every date element for year, for month, month day, week day, and prepended these tokens to text. So the first token is always year embedding, second is month embedding, third is month day, fourth is week day, and every next embedding is embedding of text tokens. Okay. Second approach is adding embedding to every input token. So instead of stacking or prepending our embeddings at the very beginning of our text, we just add these or embeddings to every input token to every word. So every embedding is token embedding plus positional embedding, which is regular for transformers, and next 4 embeddings. Okay, next slide, please. And the third approach of incorporating timestamp is just adding date at the beginning of the text. No, we don't train any. We don't train any embeddings. Just modify the input. We work only on text, not on transformer architecture. Next slide, please. And here are the results on our data sets. So in the first field, we can see most frequent number from 10. The second field is Roberta pre-trained. So it is English Roberta pre-trained with our baseline and 3 approaches. And the third field is Roberta trained from scratch. So we don't use any external knowledge, just the information in the data set. Okay. So as we can see, there is a huge difference between models which incorporated date into it and base model. So for example, Roberta pre-trained node date has accuracy of 82, and Roberta pre-trained text date has accuracy 87.8. So it's much better. So really, it's true that the temporal information can improve language model. In this case, it's the same in sentiment, data set, and it's also true in language models which are trained from scratch. But information that pre-trained models perform better, even if they are pre-trained, using this additional information is great news for us, because we don't have to train Roberta from scratch with all the corpora. Yeah? And not surprisingly, the pre-trained model is better than that not pre-trained. And we also can see that the difference between Roberta pre-trained stacked embedding date, added embedding date, text date is not very big. The difference in this case for Island News, the best is text date. In the Sentiment 140 is embedding date, but the differences are not huge. It's very slight difference. So we think that the best approach to incorporate timestamp into the model is just not training some embedding layers, just to prepend the text at the beginning. Okay, next slide, please. We also measured how each element of date affect the accuracy of the model. So we checked. So we have this model. Pre-trained nowadays is a baseline model. Roberta pre-trained text days is a model I showed before, and Roberta pre-trained text day is Roberta model with only day. Roberta pre-trained text month is a model with only day of month. Text year is model with only year, and a weekday is with day of week. And we can see accuracies for in the first column, and in the second column there is mutual information between this date factor class and between this date factor class and this category factor class. So we can see that the bigger mutual information is between date element and class element, the bigger gain is on accuracy. Okay. Next slide, please. We also did another experiment because Island News is a data set trained up to 2019. The train and development data set is to 2019, and we wanted to check how the model would perform on newer data, not included in train and development data set. So we have created another test data set, and we can see that this model incorporating date also performs better on unseen year. So it's great information. You can train a model up to one point and use it for in the future, not pre-training every day or every year. And we have better accuracy, but the gap between baseline model and including timestamp is not so big as before. Okay. So in a summary, next slide, please. So in a summary, transformer really can improve by using temporal information, and in our opinion, the best way is to prepending text because it's the easiest way, and there is no huge difference on accuracy. Okay, thank you, and that's all. Thanks for your attention.
Yeah, interesting talk. Actually, I also did Twitter the sentiment before, so that's why I have some questions for you. Actually, I relate to your base model. Actually, is using sentiment 140, right? It's quite many years ago. So that's why you compare that model with your latest airline news is 2 years ago. So because I want to highlight one thing is actually because Twitter already changed because it increased the text length. Yeah, initially it's only a few words only can be tweeted, and now actually the Twitter has been changed. So that's why a lot of the news, like the posts or text, some of the reference rule can be applied into the new Twitter lens because the length increase. That means you have more features inside. So that's one of the things. Okay, so can I go back to your page 18? Yeah.
Slide 18?
Your slides 18.
Okay.
Yeah.
Can you go back to slide 18, please?
Yeah, this one. So actually from here, so what's your meaning of the most frequent from train is roughly only half. That means for us is the classification is very bad. That means just guess, just like one.
Sorry, I didn't.
You mean the 51, right? 51 and the sentiment 49 something, just like I thrown a coin, right? It's half. So actually there's nothing. So, and you use your Roberta pre-trained the text data, so you can increase the this accuracy, right? Here your number is accuracy or is the recall?
So is accuracy the most frequent?
It's accuracy, right? This value is accuracy.
Yeah.
So now you increase your accuracy to 87. Actually, my doubt is why the most frequent from train is only 51.
So sorry, because I didn't explain it. Thank you for the question.
Yeah.
So the most frequent from chain is the most frequent label appearing in the train dataset. So in the island news, it was news category. So it is a very null baseline null model. So for every sample, it's just news. And for sentiment, it's balanced dataset. So it's always positive sentiment. So it's very baseline. In island news, we had 8 categories.
It's your 8 categories or your six categories?
I think it.
I think in the beginning you mentioned it's 6. I think it's news, sports, business, lifestyle, opening.
Can we go back to slide 5, please, or something like that? Oh, we can stop here. Okay, so it's business, culture, lifestyle, news, opinion, sport. Can start? Stop. Thank you.
6, right?
Yeah, 6.
Yeah,
you're right.
6. Yeah. Okay.
But it's not balanced. So the baseline model is not like 15 or 20%, but is like 50 because we also we always returned a news. So news is 50%.
Okay, then it's okay. It's okay. Because I want highlights because now Twitter increased the text length. Yeah. So maybe you can use more posts or reference or chunking. There are a lot of things inside. Okay, that's good. Cool. Thank you. Yeah.
Thank you.
Okay, so maybe a final comment from you. How is it different, this classification of these short messages compared to other messages, and maybe how can this be applied in information retrieval, like if you have a very short question and then retrieving the relevant document?
Okay, so I did another research in this temporal research, and I was experimenting on long text, and the improvement on long text was very slight, or there were no improvement, because I think it is because the language model could guess which year because the language model is good at guessing which year the text is originated. So we think in the longer text it's easier to find temporal information, but in the short text it's difficult. And how can it be used to improve, for example, search engines? For example, we have some search engine, for example, Allegro or eBay or Amazon. We want to given a search query. The search query is usually very short. We want to predict which category the user is looking for. So using this query and temporal information, we can predict the category and return better results for the user.
Okay, thank you very much for your answer.